Hi, Pharrell BIM team. Today I'm going to do a quick tutorial on how to pin diagonal members in case this comes up in other projects. So the idea here is that we're trying to find the pin location for these kind of diagonal members. We have three surfaces, one over here, and one here. As you can see from the side view, it ends up looking like this. So we have to find the pin in the location here. So I already have it on the right side just to illustrate what the final goal is, but I'll show you how to go about finding this on the left side. And so let's begin. We're going to want to open up Dynamo first and give it a couple minutes. A little bit more background about this. One of the neat things, I'm just going to ramble while we wait for Dynamo to open. One of the neat things about this is that we're going to be trying to find the most horizontal member, but we can also do the same thing for vertical members, or not vertical members, but to find the kind of pin location for a vertical, and that would be a column. So we can find the kind of exact intersection from two different floors of two different members going in arbitrary directions. I've used that in a couple places, so I'll go into how exactly we would go ahead and do that. This is going to be a bit longer of a video than usual because it's more of a tutorial than just an explanation of how to use the script. This also will explain the logic of how we go about finding a new script. So obviously we'll start a new script, and what we're going to want to do is first decide what our inputs are going to be. In this case, if we look back over here, I want this pin location to be from the center line of this exterior face and this exterior face. So our inputs are going to be the exterior faces. Let's go ahead and do that. And if you're not aware with Dynamo, you can either set it to automatic or manual. I prefer to do automatic in the beginning, and we'll switch over to manual as our script gets more complicated in order to just speed things up. The problem with automatic is that every time you make a change, your script will rerun. If your script takes a while to run, then every change will take about 3 to 4 seconds to finish. So 3 to 4 seconds to change just makes it kind of hard to iterate on. So we're going to start with select face. I want 2 of these, one for each exterior face. Let's go ahead and select those. So this exterior face and this exterior face. Now we have a background preview, although it's a little bit hidden, so we can go ahead and zoom in to that. And as you can see, we have 2 exterior faces in arbitrary space. What is it? There we go. So you can see these are going to be what our input working elements are going to be. But we want to find the center line of these faces. I find the best way for these kind of long rectangular faces is to do a deconstructSurface. And of course my Dynamo has messed up. Well, sorry, as you can see, that little hand just means that Dynamo has messed up for a little bit. There we go. Let's fix that. That's the bug in Dynamo. Sorry about that. Anyway, so as I was saying, we can do a deconstruct surface. In Dynamo, if you have something selected and you hold Control and then drag it, it will give you another one with the same inputs. We'll have to remember to always change those inputs. And so you can kind of see this in the background here, that you now have this black outline and these dots. Those are going to be the points that we have just created with these. I find, to kind of better illustrate what I'm looking at, we can do a translate. I want to translate the geometry. So just because everything is all located in the same location here, just to be able to see what we're looking at, we can go ahead and raise it up, say 4 feet. And we'll look at, say, the edges. And so you can see this is that. Or if we want to look at this one's points, you can see that. And that's the nice thing about being in automatic mode, is it will always just show as you want. We'll get rid of that for now. And what we want to find is the center line here. There's two ways of going about this. You get the UV parameters. I don't prefer this way. The way that I'm going to do it is lineByBest fit. For each of these points. Now this will work on these kind of long shaped rectangles that come up a lot in steel members, but it won't always work, because if there's something that changes the geometry, or if there's extra points, you might want to use the UV center line. In this case, we're just going to do this because it works. And just to illustrate what we just did, we got the center line. You can kind of see in blue here, or like I was saying, to better see it, we can go ahead and just move it up. This is actually creating two lines. There's one, the blue one that's still there, and then the geometry that's been translated. So we have two of these, which is what we want. Now, the simplest way to do this would be to simply do closest and get closest point to. And we can run two of these. With alternating inputs, and then we can also do a line by start point, end point. And might be a little bit hard to see, but what we did was created a line between these centers here. So that is the absolute shortest distance between these 2 points. However, as you can see, it's the kind of strange diagonal. It's not necessarily what we would want, especially for a pin. Ideally for a pin, it's going to be as perpendicular to these two surfaces as possible. So I really was just doing that to show how this closest point to works. But we don't actually want to use these. That is what we'd use if we were going to, say, have two perpendicular members. That would be the simplest. To say we were trying to find the column between two crossing horizontal members. In this case, we're going to get rid of all of these. And we're going to use a little bit of vector algebra. So what we're going to do is grab the z-axis. This is simply a vector pointing straight up. A vector is a magnitude and a distance. The z-axis, because it's kind of an origin vector, it'll have a magnitude of 1 and be pointing just straight upwards, so 0, 0, 1.0. And we can go and create a wash just to prove this. And because we're in automatic mode, it'll show up as soon as we show it in. So you can see that is our z-axis vector. I'm also going to want to get the direction that each of these center lines is pointing to. So I want a vector for each of the two center lines that we've created. For this, what we're going to do is called tangent at parameter. Let's look at the tangent to a curve at a parameter. In this case, the default is 0. Since it's a line, not necessarily a curve, it doesn't really matter where we get the tangent from. So now we have those, and we're starting to go back to high school math. We're going to grab the cross product of these. So I want the cross product of the z-axis and the direction of the line. Now these, because they are vectors, won't show up in geometric space. Vectors don't exist within geometric space. So we don't actually know exactly which way they're pointing, because we're not sure if the tangent at our curve is going diagonally down or diagonally up. But what we can do is to extrude our curve, extrude our curve, and we're going to do the direction and distance, because if we simply did a regular distance, it would be the distance of the cross product vector, which would, I believe, is normalized to 1, and we don't necessarily want a 1 foot extrusion because we're not sure if these two are 1 foot away or more. So we need to get our original curve and this direction, and we're going to do the same thing for this side. It defaults to 1 anyways, so this is what it would look like. So let's get our other curve and this cross product direction, and as you can see, they are actually facing in the wrong direction. That's quite alright. There's a couple ways of fixing this. I also want to show you one more thing. If we go into View, Background 3D Preview, and we're going to go into the Revit Background Preview. This is just helpful to visualize in Revit. So now what we see in we turn that off. I don't know where this one went. That's fine. Anyway, we can now see this in Revit. So this is a little bit easier to understand all the geometry that we're working with here. We can see our lines and points, and the extrusions are these orange colored ones. So to switch these, we simply need to switch the cross products. So instead of that, we're going to do that, and this will go here, and this will go there, and now we have them facing this direction. These are 10-inch members, so as you can see, it's really not long enough to even touch each other from the exterior faces. So we're going to go ahead and change the extrusion distance. Let's make it nice and big. Let's go ahead and just do 4 feet. That might be overkill, but it's better to have too far than too little. You have to have everything unselected for this to refresh. Okay, so now we have, as you can see, 2 extruded faces facing at each other. This is all that we need. And then in this case, we're going to go ahead and find where they intersect. And because we have two surfaces, what it should come out with is a single line, as we can see right here. Now this line, because these surfaces were extruded in the cross product of the z-axis, which will give us horizontal extrusions. It will not be perfectly horizontal because we're going between this, and there. Well, there might be a different way of calculating it, but I find that this is going to be the shortest horizontal, if that makes sense. And I'm sure the engineers can discuss on the best way of calculating this later on. But this will go from the center point of the exterior face to the center point of the exterior face in the shortest distance. So now that gives us a line. You can also check in Dynamo by doing this. This is also a good way of checking your list structure. So as you can see, we have a list within a list. Because we're just doing one at a time, we can go ahead and flatten these. To have a easier structure to work within. Once we've gone ahead and done that, we're going to do finally translate that over into Revit. So this is going to be beam by curve. Let's go ahead and choose a level for that. I'm not sure exactly what level, so we're just going to go ahead and check in this guy. We have level 2. That's fine. We'll grab the level that we want to assign to the beam. Level 2. And finally, let's get the structural framing type. And we want an HSS 7. Now, since we're in automatic mode, that should have made this appear here. And it did appear there, but as you can see, it is higher than we expected. Or, well, it's not centered as we would have expected it to be. That's fine, we're just going to go ahead and fix that in Revit. At this point, we can go ahead and save this. This is going to be called this pinning demo. In case we need to come back to this, if it gets deleted or something. We don't need this script anymore though. Oh, if you quit Dynamo without turning off the Revit background preview, the background preview will stay. So keep that in mind. Let's go ahead and get rid of that. It is nice that we can see the center line, and that just to know that we are on that center line. Let's go ahead and open that again. And because we're in automatic mode and we just reopened it, it'll actually try to run the entire script again. It's in fact deleted the old one and created a new one in the same location. It's nothing really to worry about. However, if we were to choose new faces, it would delete this one and redo it. To get rid of this, we can just Control-C to copy this one, and then I like to repaste it in later. That will break the connection to Dynamo between this member and Dynamo. But the reason we opened this up was to go to background preview, available previews, and hide that Revit background preview. Oh, but it's still there because we broke it. That's okay. Next time we open up this, can we get around that? I believe we can. Let's do this so that we can show what project this is, and then reopen that view and I believe the preview won't be there. No, it's still there. Never mind. Anyway, it'll disappear eventually, unless I got set up the wrong one. No. All right, Dynamo bugs. Don't worry about it. This geometry is not permanent. It's just in memory. No way to get rid of it for now. So close that. Don't worry about this. So lastly, we're just going to select this. We're going to move this to center. Add whatever extensions we want. So now we have a pin that is horizontal and going through the center of each of these. And lastly, if we want to be fancy about it, we can go ahead and go to cope and cope our members using our pin. Now you can see, you can actually see through it. So that's the basic way of using the pin. And like I was saying, we can actually do the same thing. Can we do it over here? Anyway, it wouldn't quite work over here, but we could extend the line if you wanted to do use the same concept for adding columns between framing. I hope that this is helpful and explanatory. There is a script that you can just run through Dynamo Player that will allow you to do this without having to draw out the graph yourself. However, it is important and helpful to know exactly how our graph works. So that is that. If you have any questions, go ahead and contact me. You guys should know my number. So bye. Hope you guys have a great day.